All right, for this graph here, again, when we graph our logarithms, we're going to start out with our parent function, which means you just take the log of whatever base they give you. So they gave us base 4 of x. So we're going to ignore this plus 5 and this minus 2 just for the beginning. We're going to grab our 2 points. Remember, they're always 1, 0. That's always a point. Okay, so just plot that down. 1, 0. The other one is whatever your base is. So my base here is 4 will map to 1. So it's always base 1. 1, 0, base 1. So 1, 2, 3, 4, and up 1 right there. So normally my logarithmic function here would look like this. It gets really close to this nice lovely asymptote at 0, 0. Okay, so that is our parent function. Now, we do have to make a few transformations right here. So when you look back up here, there's a number grouped in here with the x. That's going to be our horizontal shift. That tells us, remember, horizontal always go the opposite way. So that's going to tell me my points are going to move to the left 5. Both of those points, I'm just going to pick up and move to the left 5. However, I'm also going to move them. This is a vertical shift, so I'm going to move them also down 2. So you could do these in 2 separate ones. I'm going to do them in one. So let's go ahead and just do it once. What I'm going to tell you to do first, though, is to move this nice lovely asymptote. Remember, our logarithm could never be a negative number. Now, since we're adding 5 to it, we're going to move this back 5. This lovely asymptote is going to go from here over 1, 2, 3, 4, 5, and go right here. Okay, so our asymptote moves as well as our points. So now we can never get a number smaller than negative 5. But let's pick up those points right here. We're going to move them over 5 and down 2. So this point right here at my 1, 0 is going to go over 5. 1, 2, 3, 4, 5, and down 1, 2 right there. Same thing with this one. My 4, 1 is going to go over 5. 1, 2, 3, 4, 5, and down to 1, 2. And then I'm going to go ahead and erase these before I connect the dots. But let's erase our old asymptote here. Whoops, I just erased my dot. So let's actually put the dot back in here. 1, 2, 3, 4, 5. 1, 2. There's my dot right there. Now we'll erase our old one. And then you could connect those pictures. Remember, it cannot pass that asymptote. Okay, it's just going to go really close to that negative 5, but never cross it. All right, this time our domain switched again. Anytime you have a horizontal shift, domain is going to change. Okay, so this time the smallest x value I can get is negative 5. I just can't get anything on the left negative 5, but it goes clear out to infinity there. Then my y values are always going to be negative infinity to infinity. This arrow goes up for forever, this arrow goes down for forever. Cross off the x-intercept. That asymptote was what we moved. We moved it left 5, so you're just going to say x is equal to negative 5. And then look at the pictures. We read left to right. As we follow along our graph here, are we increasing or decreasing? Our y values are increasing. They're going to slowly go up. So we're just going to use this domain right here, negative 5 to infinity, as our increasing interval. It's not decreasing. And our end behaviors, our last thing we're going to plug in right here, we're just going to talk about the two ends. Okay, so again, it's never going to cross that asymptote right there. So negative 5 and then infinity. So x is going to go to negative 5. X is going to go to positive infinity. So your y, or your f of x, over here where x goes to negative 5, here's my negative 5. We're getting really close. But notice how your y values, your f of x values are going down. So we're going to write a negative infinity there. Over here on the right side, as my x goes to positive infinity, my y values are slowly increasing. They're going up towards infinity right there. All right, that one's all graphed. Let's try our last one right here. This one has this one's a great one. Now, you've already taken your test, so this isn't going to be tested, but it's still important for you to know. So I am, again, going to start off with just our parent function, which is just the natural log of x. Okay, so we're going to ignore the 3 that's multiplied and ignore this 1 that's subtracted for just a minute. Now, we've got two points that we're going to graph. Again, always your first one. Oops, there we go. Always your first one is going to be 1, 0. That's always a point right there. The next one is your base. Well, what is your base right here? Remember, the natural log of x is really log base e is going to map to that 1. Now, e is a number. It's really close to 3. It's just under 3. It's like 2.78. Okay, so what I'm going to do is I'm going to go over really close to 3 and then go up 1. So can you see that right there? Again, it's just going to be kind of a approximate. It's just right below that 3 right there. So just note that. Your calculator knows that. If you forget, you can ask it what e is. Okay, and then the last thing, make sure, remember, your asymptote here starts at the 0. We might have to shift it, but it's always going to start right there. So there was our picture, right, like that. All right, this 3 right here, now let's do our transformations. This 3 right here, if I put this 3 back in, what that does is that stretches it, or it multiplies all of our y values by 3. So right here, my y value is 0. 0 multiplied by 3 is still 0. So that point gets to stay. But notice right here, my second point, that y value was 1. So I'm going to multiply that by 3 and just move it up to 1 to 3. So 2e or 2.78 and then up 3 right there. So your graph stretches a little, it gets a little higher. It still doesn't cross that asymptote right there. Okay, we've got one more transformation. So I'm going to write some of these. I'm going to erase this red one right here so that we can go ahead and do our last transformation. This -1 right here, it's not in parentheses, so this is a vertical translation. It's just going to move all of our points down 1. So this point right here that was my 1, 0 is going to go down to -1, 0. This point that was E3 is going to go down 1, so it's going to be E2 right there. Okay, my asymptote never changed. Again, I am going to erase these gray points. And then we're going to redraw this green line right here. So going through those points and then getting really close to our asymptote that didn't change right there. Okay, so my domain here is between 0 and infinity. I didn't move my asymptote at all, it just stayed right there. My range is always -infinity to positive infinity. Don't worry about the x-intercept. Again, my asymptote did not change. It still is x equals 0. And then just check your graph as we read left to right. Notice we're increasing. So you're going to put this 0 to infinity on my increasing. It's not decreasing. And then just go ahead and say, okay, as my x goes to the ends of the domain, so as x goes to 0 and x goes to infinity, what is my y doing? Well, my y, or my f of x, over here as we go to 0, as we get really close to this 0 asymptote here, this side is going down. It's going to -infinity. My f of x is going up slightly, but it's going to positive infinity right there. Okay? And that is us finished with our graphing.